So I'd like to now introduce the second speaker, which is Riley Vanderloo, who is the Engineering Manager for Acacia Energy, to come up and speak about power quality and power supply. Riley is an electrical and electronics engineer with a bachelor's degree with honours from RMIT. Riley has developed a proprietary software cloud-based platform optimised Bitengine OBE. Riley has developed renewable energy solutions for complex sites and specialising in demand management, VPPs, C&I battery storage and synchronisation of behind-the-meter distributed energy resources to the grid. Thank you, Riley.
Thank you very much, Brad. Appreciate the introduction. As you can see, I get a little bit too excited by this sort of stuff, but I'm here to talk about essentially what Brad introduced, power quality and security. Splitting it up into harmonics, sag swells, transients, flicker, and then blackouts as well. First up, we've got harmonics here. Now this is going to get a little bit technical, but what we can see on this graph is in our green wave is our fundamental harmonic. That's our 50 Hz sine wave that we receive from the grid, and that's perfect. That's what we want to see. In our red and our blue, we see harmonic waves. These are the 5th and the 7th harmonic, which is 5 times 50 Hz and 7 times 50 Hz, so 250 and 350 Hz respectively. When we have harmonic distortion, we end up with a distorted wave that both constructively and destructively interferes with our fundamental, and we see a resulting yellow wave. This wave is caused by loads within your facility and they're non-linear. What's that mean? A non-linear load is a load like a VSD, computer equipment, or LED lighting. And when we have non-linear loads that end up in harmonic distortion for your facility, you'll end up with additional losses and you'll end up eventually with damage to your equipment. Harmonic distortion causes in motors heating losses and therefore reduces their effective lifespan. It also introduces additional currents in all of your switchboards throughout the facility, meaning that you may see nuisance tripping of your circuit breakers, or you may need to increase the size or oversize your infrastructure to deal with these harmonics. On a lot of our newer sites where VSDs are far more prevalent than on our older sites, we're starting to see more and more issues with total harmonic distortion. Our next fun one is sags and swells. These ones are transient issues and a little bit more observable. You'll see these happen. You'll see lights turning off. You'll see interruptions to plant, or you may see damages to your plant as well. So on the left-hand side, we've got our normal voltage. That's your 400 volts or 230 volts. In the middle there, we've got a momentary sag. These sags last somewhere between typically a couple of milliseconds up to several seconds. And on the right-hand side, we see voltage swells. Unlike your harmonics, most of these issues are actually caused on the network, external to you, and especially on overhead networks. So if you're in an older part of a distribution network where everything is overhead, you will see far more voltage sags, not so much swells, but far more voltage sags than someone who's in an area that has a new underground network. And that's because sags are typically caused by branches and other stuff coming into contact with the lines. These sags cause equipment to basically stop. You run out of voltage, your equipment can no longer operate. What happens is that we see interruptions, you see plant drop out, which can, in some critical situations, cause loss of product, downtime, cleaning, all sorts of other issues. Swells are slightly less common. They're not caused by bird strikes or branches on. They're typically caused by switching of equipment on networks. So if the feeder drops out to another part of your network, you may see a momentary swell. It's also caused by switching of large loads. If you have large motors or somebody near you has very large motors, them switching off can cause the voltage to swell momentarily as well. With plant that is designed to handle these, and our newer plant, sags and swells are of less issue, especially if they're mild. Where we see sags and swells that are of significant duration or depth, that's when you start to have issues with your plant. Moving on to blackouts. Blackouts are similar to our sags and swells, and maybe I should have rephrased it, but a sag can be thought of as a brownout. It's a momentary dip in your voltage. A blackout is a more severe sag. It's a sag that drops to 0 voltage and is of extended duration. By extended duration, I mean anything longer than about 10 seconds. Anything shorter than about 10 seconds is still classified as a sag. And what we see a lot of on networks, especially on low voltage distribution or medium voltage distribution networks, is that all of the feeders connected to a substation, if you have another feeder that is impacted by a strike or a branch coming down, the network will operate what's called a recloser. So they will momentarily remove power from the network to try and clear the fault. That recloser operation is about 10 seconds, so they'll open for 10 seconds. Hopefully that branch has fallen down off the lines and they'll reclose. If they're able to reclose and power stays on and there's no longer a voltage dip, that recloser will remain on. You'll only have your 10-second outage. If it's a bigger event, like someone's actually crashed into a pole, taken out that network, that recloser will open again and you'll be in a blackout situation. There are, of course, other causes for blackouts, such as AEMO's load shedding, which Steve mentioned previously in our unprecedented market suspension. We got very, very close to rolling blackouts across the national electricity market, where for up to 45 minutes at a time, specific sections of the network will have no power. So that one is probably the most obvious because your lights are out. Nobody can see what they're doing, and your plant is definitely down unless you have some sort of backup internally. Moving on from there are transients. These are momentary spikes in voltage and are most typically caused by lightning. The one on the left you can see there is a lightning strike. The one on the right is actually caused by normal network operation. So when we operate these reclosers, or when the network operates these reclosers, we get standing waves. So electricity does take time to travel down your line. It moves very, very fast, but it does take time to travel down your line. And we get reflections back and forth across the line, which, similar to our harmonic distortions, constructively and destructively interfere to form a nasty little spike there as well, which again is normal part of network operation. But if you are not protected against these spikes, they can cause damage to especially sensitive equipment. The scale on this diagram isn't fantastic. Typically your voltage spike due to a lightning strike or a nearby lightning strike will be significantly greater than the voltage spike caused by recloser operation, but these are the two types of transient issues that are quite common, especially on high voltage network, especially on overhead networks for your lightning strikes, but underground networks and overhead networks both have issues with transients due to opening and closing of circuit breakers or reclosers. Flicker. This one is much less likely for you guys to have any issues with, unless of course you are operating something like an arc furnace. Flicker is named because of the effect it has on lights. You can visibly see it, it's annoying as hell. Just like harmonics, it can cause additional heating issues and it can cause issues with very, very sensitive equipment, but typically this is something you will experience as a result of somebody else's operation on the network, not as a result of your own load. Networks and customers that are causing this issue must reduce to a mandated level, which means that you're unlikely to experience it, but for rounding out our power quality and security, couldn't miss Flicker. All that was a little bit academic, so if that went over your head, I apologise, but where we get to is where the quantifiable loss is, where these things cause issue, what you can do to resolve these issues, and what the best practice is to getting to a solution. So where we always start when we do these power quality studies and work with customers is we're looking for the customer to be able to say to us, we have a problem and this is the extent of our problem. Critical to resolving any of these power quality issues is the amount of money it is costing you in downtime, lost production, labour, etc. Without knowing the amount of damage that these issues are causing, it's very, very difficult to come up with a solution. I'll give you an example. We worked with a dairy processor up in Shepparton used to be called Freedom Foods. They were experiencing on Powercor's overhead network significant SAG events, somewhere between 8 and 12 events per year, which would drop out their critical services. So these are their boilers, compressors, chillers, that sort of stuff. What they were also dropping out is their PLCs running their production lines, which resulted in about $100,000 of loss every single time they had one of these events, because they'd lose their sterility tags. They'd lose their sterility, a tag in a PLC. So their sterility that says that their plant is sterile. As soon as those PLCs dropped out and they lost their steam pressure, they were no longer able to guarantee that their product was sterile. That meant they had to dump a couple thousand litres of milk. They then had to wash down all of the equipment, which was a 4 to 6 hour exercise before they could restart. So it was about $150,000 worth of loss 8 to 12 times a year, which is significant. And they knew that going into it. They said, we have this many, this is what happens, and this is what we need to do to fix it. We came in and assisted them by essentially installing some distributed UPS systems, so uninterruptible power supplies on these little PLCs to keep all of the valves and to keep their sterile tags on. We also installed a much, much larger battery backup system to keep their boilers and their compressors online, which allowed them, in the event of either a SAG event lasting less than 10 seconds or a full blackout up to 4 hours, maintain the operation of all of their valves and keep their steam pressure. So because they had such issues with their SAG install, they had such sensitive equipment, the payback on the installation of this was less than 2 years, which is phenomenal for a battery system. That's one of the more extreme examples, but critical energy security, or electricity security is critical for these processes, especially where you have very, very sensitive equipment.
Okay, thank you, Riley. So next poll, everyone, if you can please reopen your devices and you'll see this question: what supply security and quality issues does your business need to address? Riley, I think if you want to... So what I'd like to do is, whilst people are answering that question, you and I have been out on an appointment at a manufacturing plant, and we've spoken to the maintenance manager and we've spoken to the CEO of the operations at that point in time, and they're experiencing loss like this, and they're experiencing SAGs. They were also experiencing brown and blackouts, but there was no quantifiable loss in terms of understanding how to predict that process or understanding how to quantify that. So the question that you asked at that particular point in time is what are the natural steps and the practical steps that you are taking in order for us to be able to understand if there really is a justifiable validation in anything like a backup storage. So can you just give everyone in the audience some practical steps to take if in case you notice any of these behaviours?
Yeah, fantastic. So look, with any of your energy security or electricity security, more to the point, there are a myriad of techniques that we can use to increase your security, ranging from a few $1,000s up to tens of millions of dollars. If you're unable to quantify the loss that you are seeing as a result of these quality issues, it becomes very, very difficult to design a solution that fixes those issues. One of the most critical things that you can do, even before engaging any consultant on a power quality study, is to actually log the losses that you have. This is just a basic human log. You say, okay, on this day, I saw this bit of equipment down and we lost so much product, or we lost so much production time. It cost us approximately $5,000, $10,000. Logging that for even a month or two is fantastic base knowledge before a study happens on a more in-depth level. But yes, just having an understanding of how it's affecting you is critical to move into a solution.
Okay, so that the measurement and verification post that log time, what kind of infrastructure is required to install on site in order for them to gain further insights around those decision-making processes to ensure that they've got the right equipment in place?
Yeah, so in addition to your sort of quantifiable loss, the issues that you're receiving, when we come in, or any sort of consultant comes in, we need to understand the issues that you're actually seeing. Is it a harmonic issue? Is it sags and swells? Is it flicker? And the way we do that is by installing a power quality meter. These meters sample that sine wave you saw a couple thousand times a second and give us really, really clear data on the issues that you're having, which then allow us to very, very clearly design or specify products that will resolve those issues.
Very good. Thank you, Riley. Let's have a look at the poll results. Let's see if this surprises you. I think we've got a dead split here, mate.
We do, 50-50.
So power security, and both power security and power quality are an absolute even split on the poll. Does that surprise you at all? Is that about right?
I guess it does surprise me a little bit, but maybe because I wasn't thinking too clearly about it. The security is a lot easier to see. It's blackouts when you have problems or you have issues, or you even think that, okay, if I had a large outage, how much is that going to cost me? And a lot of businesses don't think that. Your example previously, they never considered they had a 4-hour or a 6-hour outage, how that would actually affect their production. But I guess it is a little bit surprising, but I would have thought the power quality, it's a little bit more common. But yes, power security is critical, especially when you think about those times where, hey, car crashes into my pole. There's not a lot I can do about it.
Very true. Riley, thank you for your time.